my name is Callie Stanworth, and today I'm going to be talking about the better alternative to gel electrophoresis, which is capillary electrophoresis. Today I'm going to be discussing what electrophoresis is, what its problems are, what a better alternative would be, and then I'll talk about capillary electrophoresis, its benefits, why we use it more, and then at the end I'll show all my references. So for starters, what is electrophoresis? So it's the separation of DNA, RNA, and proteins. And it's just a way to view the separation of the macromolecules by using a negative charge to push the negatively charged proteins through the fluid or gel so that you can see the separation in the bands of the gel electrophoresis. So it was first developed and discovered by a man named Arne Tiselius in the 1930s, but the use of electrophoresis didn't really apply to the nucleic acids until the late 60s. And before that, they actually used a centrifuge to separate the larger and heavier molecules from the smaller and lighter ones by spinning them very fast in the centrifuge. So electrophoresis works by using a gel or fluid to filter the macromolecules. The DNA will migrate through the gel or fluid, responding to the negative current because the proteins are negatively charged, so they'll go towards the positive end. Slower and larger molecules are left behind, and the faster ones are pushed ahead. So what do we use electrophoresis for today? And we basically use it for anything that needs DNA testing. So that would be crime scenes, forensic science, genetic testing, antibody testing, and diagnosing a lot of diseases, because in your genetics there are a lot of diseases that can be diagnosed just by looking at your DNA. So the slab of gel in the previous picture had bands in it that lit up under the ultraviolet light. And these are the separated molecules of DNA. And we put dye in them at the beginning so that they light up under the ultraviolet light, because DNA is clear and you wouldn't be able to see it otherwise. So if you look, each column is a different set of DNA, and if any bands are matching between the columns, they can be from the same person. So let's say we got this band from our crime scene and this band from a suspect. Now if you look, they're identical, they're the exact same. So in this case, we would say, well, the crime scene and the suspect have the same DNA. The suspect was the one at the crime scene. Now, if they share bands, but they're not identical, these people could be related because, relatives have similar bands because they share DNA. So there are many different types of electrophoresis, and these are just a few examples. Iso-electrofocusing, thin layer electrophoresis, capillary electrophoresis, and immunoelectrophoresis. And as you can see, there are complete different branches of electrophoresis, and gel electrophoresis actually has a lot of types. There are a lot of flaws to electrophoresis. It's a very technique-sensitive method, and if you mess any of the techniques up, it'll negatively impact your results. And there's just a lot of inherent flaws with the process. A big flaw is sample contamination. Like stated before, human error is a big problem with this method. Any environmental contamination can cause the sample to become inaccurate. Bands can be added, missing, or blurry. You can tell if your sample is having problems by checking the bands for these kinds of issues. Gel electrophoresis is very technique sensitive. It requires certain amounts of time to process, and if time goes over or under, your results are also going to be negatively impacted. For example, if your time goes over, your DNA will actually migrate off the edge of your gel because you went over. And if your voltage is too high, it can even melt the gel and smear your results. This is an example of the smeared gel. But there is a better alternative. A solution to these human error problems is the alternative form of electrophoresis, capillary electrophoresis. The difference between capillary and gel is that capillary is performed in a thin glass tube with fluid instead of gel in it. Here are some benefits of capillary electrophoresis. It's got a much wider range, which can be helpful for real-world applications, forensics. And it's more efficient when emitting heat, so that electric currents can be more powerful. And the more powerful the currents are, the faster your process will be done. We couldn't turn the voltage all the way up in gel because it'll melt your gel and it's slower. It's called capillary electrophoresis because of the thin capillaries in the human body. And the tubes used in these processes are very small, so they're like the capillaries. This process is better than the gel because it doesn't have any of the following problems: melting, time problems, contamination, overfilling, and other kinds of human errors. Adding on to our crime scene example, if a little bit of DNA was collected at the scene, then it may not be enough for the gel electrophoresis because it requires a certain amount of DNA. But the capillary does not require that much DNA to complete the process. The capillary would be a solution in this scenario because it requires smaller amounts of the samples. So the relation between the capillary and the gel, as we said before, the gel is on a completely different branch than the capillary, but they're both kinds of electrophoresis. Gel is more widely known and used for demonstration, but the capillary is the more accurate kind that you would want in a medical procedure. So there's a lot of added technology that isn't there in the gel electrophoresis. So we solve the human error issues by eliminating the human in the equation, because most capillary electrophoresis is done with a computer in control. The computer can recognize patterns, the samples can be detected, and the computer basically controls the entire process. It's much more streamlined and accurate. One key difference between CE and the gel is the way that you read it. So with the gel, you can clearly see the bands and their relation to each other. But with capillary, the data is in spikes. And each spike representing a different part of the DNA. For example, this large spike would be this large band, M1, and then this small band, M2, is the small spike. So capillary electrophoresis was developed in about the 1980s by Jorgensen and Lucas. Further developments are underway today, including new separation modes and new instruments for the machines. A paper published in 2021 by the National Library of Medicine describes capillary electrophoresis as a promising candidate for life-saving medical technology for the poorer countries. It goes on to say that its fast analytical response time and notable cost efficiency are its greatest traits. So the gel electrophoresis would be an outdated technology that wouldn't be good for the country, and we want updated technology to be safer. Capillary electrophoresis is more cost-effective in the long run because of the faultiness of the gel. The computer system behind capillary electrophoresis can detect any errors so that materials and samples aren't wasted. The only detection system for the gel electrophoresis is the person who set it up, and human errors may occur. Capillary doesn't need the extensive preparation that the gel electrophoresis requires. The process is more controlled because there's a flow of buffer instead of it just sitting in the gel. The gel is left, but the capillary flow enhances separation efficiency. A real-life scenario would use the capillary. It's a safer, more reliable, and more efficient option. So, capillary electrophoresis also has life-saving potential, because like I discussed earlier, it can solve the DNA, and it can find any diseases in the DNA. Here's just a couple of them: anemia, sickle cell disease, myeloma, and abnormal proteins. So myeloma is a type of cancer, and it can be detected with the electrophoresis. by looking at the abnormal proteins in it. Electrophoresis is still important today. Even though the technology is almost 100 years old, we still use it. Today, it's most often being used in diagnostic medicine, biochemical research, and forensic testing, because these are still important and we need the DNA testing materials. In conclusion, the concept of electrophoresis is very simple. It's the use of voltage to separate macromolecules like DNA and RNA. There are different methods to see the separation, but they all get the job done if they are performed correctly. And here are all my references. Thank you for watching. Have a great rest of your day.